Hey there, and welcome to the Deep Dive. Really glad you could join us today. We're jumping into something pretty interesting in JavaScript.
Yeah, we've got some source material here talking about a challenge that crops up a lot with asynchronous code. It's called inversion of control, specifically with callbacks. So our plan is to unpack that, look at a, kind of disastrous real-world example from the sources, and then see how promises offer a much better way.
Absolutely. I mean, async operations are just fundamental for the web today, right?
Okay.
Fetching data, handling clicks, you name it. And understanding how we manage that is key. Callbacks were, and often still are, sort of the first tool people reach for. Basically, a callback is it's a function you pass into another function as an argument. The idea is the function you passed it to will call your function back later, when it's done its thing. The sources highlight this as the most basic async pattern in JS. Right. Like you can picture it. Okay, step A and B, they happen right now. My code's in charge. But step C, that has to wait. Maybe for an AJX call or something. So you write the code for C, but you don't run it. You hand it over to the AJX6 function and say, you run this when you're done. And that handoff, that's where this whole inversion thing starts. And yeah, that leads us right to this term, inversion of control.ioc. It sounds fancy, but it really just means you take a bit of your program, the part that says when something should happen next, and you give that control away to someone else's code.
Exactly. And often, like you said, it's some third-party utility, maybe a library you didn't write. You don't totally control it. You just hand over your function, your callback, and there's this kind of unspoken agreement. Mm-hmm. You expect to be called once at the right time, no errors swallowed.
But that's the catch, isn't it? The expectation. Most times, it probably works fine. But the sources point out, when that unspoken contract breaks, oh boy. Let's use that example we found, the travel booking site. Really paints a picture. So imagine you're building this site. User clicks book now. Your code calls create booking, which is, let's say, part of some external library you're using. That function is supposed to do its magic, process the booking, and then this is key call your function back so you can send out the confirmation email.
And it seems fine at first. You test it. Maybe it works in staging. Looks good. You launch. Then, bam, a customer books a trip. Just one trip.
Yeah.
And they get not one confirmation email, but four. 4 identical emails for the same booking.
Oh, man. Yeah, so you dive in, right? Check your email code first. Looks fine. It's built to send one email per call. So you trace it back. And you find out the create booking function, the third-party one, it actually called your email callback 4 separate times.
So you contact the library vendor. They look into it. And they come back saying, whoops, yeah, sorry about that. We had some experimental code slip into the release. It caused the multiple calls. We fixed it now.
Okay, so the immediate fire is out. But you're thinking, right, can't let that happen again. And the first instinct, maybe you feel a bit clever, is you go into your callback, the email sending one, and add a little check, like a simple if statement. If, already sent, problem solved. Team feels okay about it, for a bit.
But then, someone, maybe a sharp QA person, looks at that fix and asks the killer question. Okay, that stops the too many emails problem, but what if they just never call the callback? At all, and you just freeze? Because honestly,
hadn't even crossed your mind. Exactly. That one question just cracks it wide open. Suddenly, you're thinking about all the other ways this third party, the one you trusted, could mess up handling your code.
Right.
What if they call it way too early? Before things are really ready? Or too late? Or like the QA person said, never. Or too few times. Or the 4 email too many times problem. And, the really insidious one. What if their code throws an error before it even gets to calling your callback and they just catch it and swallow it? You'd never even know something went wrong.
Mm-hmm. And you start realizing to really protect yourself against all those possibilities, you'd have to litter your code with checks and balances and timers and flags for every single callback you pass out.
Yeah.
The source material called it awful and dirty code. And it's all because you fundamentally gave away control over your program's continuation.
So it begs the question, right? Is there a way to flip this? To uninvert the inversion of control? Can we get that control back where it belongs?
And that's exactly where promises step in. It's a really fundamental shift in thinking. Instead of you passing your function to them, they don't take your function. Instead, they immediately give you something back. An object, a promise. Think of it like a receipt or a placeholder for a future value. It's a capability that represents the eventual outcome of their task.
Yes. So your code holds on to this promise object, and you get to decide what happens next. You attach your logic to the promise, saying, okay, when this thing finishes successfully, then do this. Or if it fails, then do that. You're back in the driver's seat.
Right. Promises provide this much more structured way to handle async stuff. People talk about them solving callback hell, that deep nesting, which is true. But I think more fundamentally for this discussion, they solve the inversion of control problem. You manage the async flow without handing over the keys to your code's execution.
Totally. And the cheeseburger analogy from the source, it's perfect. Think about ordering at a fast food joint. You pay, right? You don't just stand there staring at the kitchen.
No, exactly. They give you a receipt, maybe with a number. That receipt, that's the promise. It's their promise to give you a cheeseburger, eventually.
And with that receipt, that promise, you can go do other things. Fill your drink, find a table, whatever. You're not blocked. Then your number's called the promise is fulfilled, resolved, and you get your burger. That's the success case.
Or maybe they run out of cheese. They call your number and say, sorry, we're out. That's the promise handling the failure case. You know what happened. It didn't just silently fail.
Makes total sense. So the promise object itself represents that future outcome, the burger or the bad news.
Exactly. And that structure makes the code way cleaner than callback soup with defensive checks everywhere. Plus, promises have built-in ways to handle errors properly, which directly addresses that whole swallowing exceptions problem we worried about with callbacks.
So, back to that booking disaster. If create booking returned a promise, it wouldn't be create booking my email callback. It'd be more like create booking. Then send confirmation email, handle booking error. See? You're attaching the what next parts. It feels much safer, much more controlled than that awkward if statement fix we tried earlier.
And there's another really key property here. Once a promise settles, meaning it either resolves successfully with a value or rejects with an error, its state and value become immutable. It's locked in.
Immutable meaning?
Meaning it can't change. If it resolves successfully with, say, the booking ID, you can look at that booking ID from the promise multiple times, maybe pass it to different parts of your code using stone hour, and it will always be the same ID. The underlying create booking operation doesn't run again, and crucially, it cannot be accidentally called multiple times by the library, fixing our for email problem at a fundamental level.
Okay. So it's inherently resistant to being called too many times or too few, or with different results later. Once it's done, it's done.
Precisely. So, promises tackle all those ISE issues we listed. Calling too early, late, never. You control the box then. Calling too few many times, immutability handles that. Swallowing errors, explicit rejection handles that. It's like an inversion of the inversion, or maybe an uninversion. Control comes back to you.
Yeah, an uninversion. I like that. It puts the control back in your code, which is where you wanted it all along. Okay, so wrapping up this deep dive. We looked at this idea of inversion of control with JavaScript callbacks, saw how messy it can get with that travel booking example, ouch, 4 emails, and then explored how promises really change the game, giving you control over asynchronous operations.
Yeah, the big takeaway really is that promises offer a more reliable, more maintainable approach, mainly because you're not handing off that critical piece, the continuation of your code, to potentially unreliable third-party code.
Yeah.
You hold the reins.
Definitely. So maybe something to think about as you go. Where else in your code, or even just in systems you interact with day to day, do you implicitly trust some other part to call you back correctly? How does thinking about explicitly managing the next step yourself, like promises let you do, change how you might approach building really solid, dependable applications, especially when you're relying on external pieces? It's kind of a bigger idea than just JavaScript, really. It's about managing trust and complexity.